Hi everybody, welcome to another Loihi update. You guys may have caught an update that I did yesterday with Dane DuPont and Ikaika Marzo, and it's been about 24 hours since we put out our first report, and we'd like to include some new USGS information. They put out an update as well, and show you guys how the website can help you guys track what's happening with the earthquakes at Loihi, as well as give you guys a review of some of the resources on the internet and show you a little bit of a virtual tour of the underwater volcano. So, welcome you guys for joining in and joining us on the feed. All right, so what is first start off by mentioning that there has actually been just right now, as we speak, 3 p.m. Hawaiian time on Tuesday, May 12th, an alert put out by the Tsunami Warning Center. No tsunami warning for Hawaii, but here is our island map. We'll look at the Hawaiian earthquakes here in just a second. We're going to zoom out a little bit and show you guys this earthquake down over here between the Solomon Islands and Vanuatu. There's a 6.6 you guys can see near the Santa Cruz Islands that very, very deep, close to 70 miles deep with that 112 kilometers depth right there. And that has been determined to pose no tsunami threat to the islands. So that's kind of one that is keeping us on our toes a little bit as we're watching the earthquakes develop here on Loihi. But rather than use the normal USGS website that I have here, earthquake.usgs.gov, I'm going to go to the HVO website, which is part of the more dedicated, or if you actually go to the HVO homepage over here, click on earthquakes, that'll land you on this page that we're on right here. And so what I want to show you guys is that we actually have the same pattern of earthquakes as we had yesterday. We have some around Mauna Loa, some around Kilauea at the summit, a little bit of the southeast rift and a south flank. And then we also have the Pahala earthquakes that we've talked about being very deep and being related to magma movement that possibly feeds all three of these volcanoes. And then here's a new thing in the last couple of days is this big swarm of earthquakes, a big clustering of earthquakes in time and space around the Loihi volcano that right now are actually following a pattern of magma movement. Magma rising a little bit and then stopping within the volcano. All of this more than 3,000 feet below the surface of the waves. So first, let me read you guys the USGS update. An alert was just put out not quite 3 hours ago by the USGS Hawaiian Volcano Observatory. And you can see here, Loihi Seamount volcano. And I'll read it out to you guys. Earthquake activity increased Sunday and Monday in the vicinity of Loihi Seamount. I'll skip some of these little details. There is no indication eruption has occurred, and no significant hazards of concern to the island of Hawaii at this time. The observations, beginning about 3 a.m. on May 11th, yesterday, and continuing through the morning of today, HVO detected more than 100 earthquakes beneath Loihi, including 79 magnitude 2 earthquakes and 19 magnitude 3 and above earthquakes. This is a significant increase above long-term background rates of fewer than 3 earthquakes per day at Loihi, generally with magnitudes less than 2. The number of earthquakes peaked at 14 per hour between 1 and 2 p.m. Monday afternoon and decreased thereafter. Since the early mornings of March 12th, earthquake rates have been less than 4 per hour. And so let's just do a quick hop over at this point, and we can kind of see that looking here, since that alert's put out at 12:20, there's only been one earthquake, and it's actually one that's over here in this Pahala cluster. So there's been no earthquake since that alert was been put out almost 3 hours ago by HVO. So they seem to be well on it. All right, so the swarm is located beneath the southeast rift zone and the southeastern flank of Loihi at depths of 2.2 to 7.7 miles below sea level, or approximately 0.6 to 6 miles beneath the volcano surface. So that actually is getting a little bit shallower than we might have thought before, 0.6 with those closer relocations. So let me pause here as well and jump back to the earthquake page and show you guys that on this plot over here, on a USGS page, HVO USGS page that is, not the main earthquakes page, but you can click on the earthquake plots over here and select plot area, and we can actually then click a little section across Loihi here and look at that plot. This is how we get those plots that I was showing you guys yesterday online. And so here in the bottom is the actual time. This is dates, right? So our day is just yesterday and today. It's just this little window right here, not very wide. And here's the depth of it. And in this particular snapshot, it's showing relocations below 3.1 miles for the bigger ones that are showing in the website, and down to almost 8.1 miles over here, right? So you can kind of see going in time, it was all the way up to 3.1, and kind of if you look closer, there's a little arm right here to the right showing like a little bit of a cluster a little bit deeper down that kind of continued on longer than a main event that peaked yesterday. So that could actually be a sign of magma moving from depths within this range. And as it is, like there's no indication eruption has happened, as USGS said. And if there was, it might be hard to really tell apart from the seismic characteristics. But we haven't seen the characteristics that are typical of magma or breaking the surface of the ground, whether underwater or on land, and actually causing that vibration, the vibration of the ground as the fluid is being expelled, right? So we'll show you guys some videos of what that might actually look like underwater from some of the footage online here shortly. But so this is how you make those plots, earthquake plots. You can kind of see that that's a depth range that they're talking about. And so let's go back to their update now. And we can see that they're saying it's beneath the southeast rift zone of the volcano and southeastern flank. And I'll look at that here in a second, but interpretation hazard. The swarm may represent a brief magmatic intrusion or movement of magmatic fluids within the volcanic edifice. Although the swarm appears to have diminished in intensity, if earthquakes became shallower, it could lead to the beginning of a submarine eruption, similar to what occurred in 1996. An eruption of Loihi, if it were to occur, may cause partial draining of its summit chamber, and summit collapse, as happened in 1996 as well. So significant sudden changes to the surface of the volcano could displace large volumes of ocean water, which, if large enough, might generate very small local tsunami waves. Earthquakes of magnitude 4 and above could occur if the swarm were to intensify, and these may be felt on the island of Hawaii. They actually give some more context here shortly, which will be really, really useful, I think. And then they go on to say, based on the context, if an eruption or stronger earthquakes occur, very small tsunami waves may affect southeast shores of the island of Hawaii. Relatively low energy, steam and gas-driven explosions can occur at the depth of Loihi, but with limited local effects on the volcano and surrounding ocean water. There's no direct relationship between the current Loihi swarm and the ongoing increased seismicity observed in Pahala over the past year. The Loihi swarm is 22 miles southeast of Pahala at significantly shallower depths. The current Loihi swarm is also unrelated to seismicity observed on the south flank of Kilauea. Alright, so before I go into the background here, let me just scroll to the background, and then let's click back over to the HVO page, and let's zoom in a little bit here on Loihi. Let's pan over, show you guys what they're talking about, and let's see if we can see any settings here. Yeah, looks like we can't really see exactly, but you can see that the peak of Loihi is marked as right here, this little triangle right in there. And you can see above where it says Loihi, there's a ridge to the north, and then also a ridge to the south. Those are the rift zones of the volcano. So you can kind of see we're off to the right of that whole label, and that's the area of Loihi right there. So all right, let's look at the background. Loihi Seamount is an active volcano on the seafloor south of Kilauea Volcano, about 19 miles from the shoreline of the island of Hawaii. The top of the seamount is about 3,200 feet below sea level. The volcano consists of a broad summit area marked by 3 pit craters and 2 prominent rift zones, extending from the summit about 13 miles south-southeast and 9 miles north-northeast. The volcano likely has a shallow magma chamber between 0.6 to 1.6 miles deep below the summit. And that's interesting that a 0.6 mile number has popped up again as a possible location as a magma chamber. So possible movement of magma within a magma chamber of Loihi is inferred here. Earthquake activity has been recorded near Loihi since 1952. Prior swarms occurred in 52, 71 to 72, 75, 86, 88, 90, 91, 96, 2005, and 2017, and were characterized by hundreds to thousands of earthquakes occurring over weeks to months, with magnitudes ranging up to magnitude 4.9. The largest earthquake ever detected at Loihi was a magnitude 5.1 in May 2005. Many of the 1952 Loihi earthquakes were felt in coastal communities, and one of the earthquakes generated a small tsunami that swept inland about 180 meters at Kalapana. No damage was reported. The 96 swarm was one of the most intense swarms recorded by HVO monitor networks and is summarized below. For 6 weeks, there were more than 4,000 earthquakes in the area, 95 between magnitude 4 and 4.9, 400 above magnitude 3. most during the last half of July during 3 time periods, each lasting 2 to 5 days, and separated by less than 1 to 4 days. So that's an interesting aside right there, that we could expect possible flurries of these little flurries of swarms, right? So like a burst of swarms and then a period of calm that might last a few days. We might have another swarm possibly coming at some point in the future, or possibly not. It kind of depends how much adjustment it really needs. Okay, and back to their update. Subsequent undersea expeditions to the area discovered the volcano summit had collapsed to form a new crater about 1,800 feet across and 900 feet deep. Hydrothermal vents were observed in the crater, and evidence was found of newly erupted lava. For more information, see University of Hawaii School of Ocean, Earth and Science and Technology website, as highlighted here. So I will show you guys a website here at the end of our update, and we'll keep going with what we have of the HVO background here. So HVO continues to closely monitor activity in the Loihi area and will issue further updates as needed. There are no monitoring instruments on the Loihi Seamount, thus locations are not as accurate as those on the island. Significant changes at Loihi, Mauna Loa, and Kilauea will be reported through the USGS Volcano Notification System and the HVO website. We are in frequent communication with Volcanoes National Park and Hawaii County Civil Defense to keep them apprised of the activity. So there you have it. Almost 3-hour-old update from HVO issued up here. So once again, there are earthquakes on Loihi, and if you guys are just kind of tuning in a little bit late, I was just gonna recap for you guys here. You can click on earthquake plots. Let's hide this, right? You can click on select plot area, and you can click on one end and click on the other, and kind of get a little rectangle that catches a whole bunch of earthquakes. You can click on a view plot, and it pops up that window that shows there, right there, the time on the bottom and depth on the up and down axes of this plot of where the earthquake was occurring. And it is notable as the USGS update noted, this is depth below sea level. So the top of the volcano is actually somewhere down in there, right? Not actually quite at the very top line here on this plot. So let's see, let me try something here. All right. So, okay, let's move on from there and show you guys, HVO does have a dedicated Loihi Seamount page right here. Click it for you guys here, volcanoes.usgs.gov/volcanoes/Loihi. And there's a kind of a digital elevation map from the seafloor, a bathymetric image, as it's called, right? And some background information here, which is mostly recounted in what you guys have just heard on the other update. So I won't read it all for you guys here, but you guys can kind of see. One thing that's interesting, the name Loihi means long in Hawaiian and was introduced in 1955 to describe the elongate shape of the seamount. More recently, Hawaiian scholars have found stories of Kamaehu, the red island child of Haumea and Kanaloa, the sea, the earth and sea that rises from the deep ocean floor, may also be referenced to the submarine volcano. So there is the perhaps more proper Hawaiian name, but this is actually still the official name, Loihi, and that's what we refer to it as. That's what everyone knows what to call it, mostly for now. But perhaps in the future we should call it Kamaehu as well. Right? Okay. So I've looked across the internet, and I want to show you guys a little bit of what this might actually look like. And so this is images of Kilauea's eruption. When lava was going into the ocean off of the sea cliff. And this is a PBS Digital Studios special here, and what I have is I'm going to play you guys a couple of little clips of when they have lava kind of slowly moving, just kind of what's trickling from above into the water, how it forms what we call these pillow basalts. It kind of, the water has got more equal pressure, so the lava flows aren't quite as flat, they're more bulbous, and as the seawater around them kind of compresses them, it holds them inwards. They kind of eventually break that shell, come out and make a new bulb, and then flash open, and then cool again, and flash open, and cool again. So here you can see some of the video of the videographers. Right there, looking at the bubbles coming up. There is the pillows forming once again. And yeah, so this is what it looks like when it's kind of relatively mellow, right? Going into the ocean. This is a very dangerous thing to film, by the way, that the deltas where the lava was going in the water would collapse, and so you might have these submarine landslides coming down. And of course, if you're in scuba gear, you can't have any of your hoses get damaged. The visibility is really bad because of all the gases and all the sediment in the water. So all in all, it's a risky thing, and so there's not much footage that you can see that's it's good to see. You know, and there's actually some other crazy footage out there as well, taken maybe a little bit less safely than us. So, all right, let's move on from this one. You know, this is an interesting, it's a longer, under H2O PABS Digital Studios, and let me highlight the address of it for you guys here, so you guys can see if you want to find that video online. And let's move on to the next one, and this is actually a release, you know, by the Ocean Content right here, and this is actually through that linked from the University of Hawaii website. So I'll show you guys where that link is a little bit later, but I'll skip ahead a little bit, and this is a longer video, but we'll start off with a 3D animated fly-through on Loihi Volcano. So you guys can see here, we're kind of flying in from the south. Those are the summit craters, right? The newest one is that southernmost one called Pele's Pit. Now we're flying over the northeast rift zone, and now we've kind of flipped back around, going around, looking from the south again, right? Virtual 3D flyover of what Loihi actually look like. And so much of the samples of Loihi and the monitoring that was done has been done with this underwater research lab, University of Hawaii, the Pisces 5. And here it is being deployed in the water to go collect some samples. Right, there it is. And skip ahead a little bit, show you guys some of the pillow lavas on Loihi Volcano. So these are the hardened old lava flows that are kind of making up the bulk of the edifice, right, to structure the slopes of Loihi itself. And let's jump forward a little more, show what it might actually look like to have been in that submersible. Here we see jet vents in Pele's Pit, 1996. This is kind of near the peak of the summit of that volcano before it collapsed in the 1996 eruption. So that feature is actually now gone. And there is an illustration showing what it might look like to have the Pisces viewing those jets. And so this is 1997. Reading up, it says it was posted that year, but it's actually from that earlier events before the collapse, I believe. You see there's like a little shrimp swimming near there. Temperature 160 degrees Celsius. Right, very interesting, right? You know, it's some of these fumaroles might get up to over 200 degrees Celsius. A lot of times it'll be in the lower range. There's a lot of different fields of these thermal vents on Loihi. Many only around 30 degrees Celsius or so, right? So the range is kind of varies all the way up to 200 C from 30 C. Bacterial mats, all kinds of life and fish that kind of growing down there, which are interesting to note. But we'll skip ahead a little bit here and show you guys the Pisces collecting some of these rock samples, right? This has kind of been described, so then they can tell how fresh the rocks actually are. They're covered in glass. They've actually found bits of Pele's hairs, and a lot of it, what they find is what is called limu o Pele, right? Pele's seaweed. When you have lava kind of flashing and like a little flap of lava forming a very thin paper-like sheet that's called limu, like a seaweed, right? But it's actually glass. On land, those were often found around the ocean entry where you'd have big bubbles of lava exploding, and then those kind of bubble walls would get very thin and then freeze in the wind and get kind of fluttered and land on shore. Sometimes you could find those limu o Pele, but they actually find a lot of that underwater here in Loihi from looking at the lithologic reports of some of these dives. And you can see the Pisces 5 arms there. You know, looks like it's inserting a temperature thermocouple right there to measure the temperature of that event right there, right? So that's kind of how a lot of this information's coming to us. So fascinating stuff there, right, from the University of Hawaii group. So there's some other things out here, and this is actually not in Hawaii, but this is a volcano called West Mara Volcano, and this is not quite 4,000 feet below sea level, so fairly similar depth. You know, Loihi's a little bit shallower, but might give you some idea of what it might look like to have an eruption like this. And so this was eruption that happened in 2009, right, on West Mara Volcano, captured by a group funded by National Science Foundation and NOAA. And this video is put out by Woods Hole. Actually, two videos. So I'll show you guys the first one here, what an underwater eruption might actually look like. Look at that, right? You guys can see it's almost like a little lava jets coming out, but more in like the flashing pillow fashion. And you can see all the gas coming out. You can see the rain of what might be Pele's hairs and little fragments of lava. Look, there's a big landslide of lava boulders falling down the side of that little cone. There's a little bit of sound there. You can hear a little bit of a little bit of the sound wave of that kind of shock of the explosion underwater, right? Here's a second video they've put out, and they're crediting the ROV Jason on this one, right? Same group as before, put out by Woods Hole. Look at that. There's some of that limu drifting right down the water column right there in the upper part of the picture, and you can see the big boulders down below. Look at that. Amazing. Yeah, so that's something along those lines is what we believe happened at Loihi in 1996. And so now I'll kind of finish off our update with showing you guys this Hawaii Center for Volcanology page out of the University of Hawaii. It's a little bit dated, hasn't been updated in a while. There's some dead links, but this has got a lot of awesome information. It's the one that's been mentioned by the USGS in their update, just the beginning of ours here. So you can kind of see a little bit of those the profiles, the virtual tour. We're kind of take you guys through here. This page is general info. The virtual tour is interesting, so let's show you guys a virtual tour. Let's click on that. So here we are. This is actually showing the summit region right here. The 3 pits at the top of the on the right side of the image there. 3 pits at the top of the volcano. And you can see some of those views here. So let's link to the summit region. So looking closer into the summit region, you guys can see here the 3 pits, right? Some of the fish, the kind of depth profile there. Let me scroll down and show you guys some of the rocks. Fresh rock, altered by all that hot fluid that's kind of being pumped out of those hydrothermal vents underwater from all that hot water that's been driven by the magma and lava, as well as it's coming up to the surface there. So they actually talk about some other minerals growing. We'll come across that here shortly as well. But there's a summit region. Let's continue to the new pit, right? So this is a Pele's pit. This is maybe one of the more interesting ones, right? So this is a new pit that was formed after 1996. It was found as a submersible visited a few months after the eruption. It wasn't clear from their samples whether it was a single eruption or 2 shorter eruptions. It's hard to really tell. But we knew that this pit formed in the area that was called Pele's Vents. I showed you guys a video that disappeared and now was replaced by what's called the Loihi vents here on the west side with the little X on the left side of the kind of center left of this image. And then also on the right, there's another little X called the Forbidden Vents, right? Two new fumarole vents, hydrothermal vents. So crater is roughly 300 meters deep, right? So about, what's that, 900 feet, almost 1,000 feet deep, forming a collapse event near the previous high point of the summit. And it's interesting how that 1986 seismic event, we'll look at it more closely, had so many magnitude 4, almost magnitude 5 events that, might have been a similar kind of summit collapse sequence as we saw in 2018, but maybe it was hard to recognize since we're so far from Loihi and couldn't see what was happening in real time. Interesting thing to follow up on here shortly. I'm sure we'll be done. So, okay, since the pit, activities resumed, chimneys of different fluids. So some of the minerals being formed here at the bottom: pyrite, barite, pyrrhotite, morsite, different forms of the minerals as well that are kind of precipitating, kind of collecting where these hot fluids are emerging from the cracks from these chimneys in the rock, and then meeting the cold seawater and then forcing out what's been dissolved in the hot stuff and kind of forming these exit vents, right? These features that sometimes have been called beehives in some of these videos, and all different shapes and textures. There's different composition of minerals are very interesting. All right, so let's move on in our continuing tour here. The Hugo site. The Hugo site's an interesting spot. So this is actually a spot on an X here where there was for a while an undersea observatory with a permanent cable connected to land. Unfortunately, the cable failed in 1998, and the instrument's been since removed. It's no longer there, but it actually was there and collected some data for a while. And you can kind of see a little bit of what the installation should look like. There was this very long cable, was 40 kilometers long. What's that? 25 miles or so. And kind of got buried in some mud, and they actually were able to do some tests, but they weren't able to recover the installation. So they pulled it out, and I'm not sure where it was been deployed, but it might have been deployed somewhere else, was the intention at the time. So let's move on to the south rift of the volcano. Here's the south rift of Loihi on the University of Hawaii Center of Volcanology website. And this is all run by Professor Ken Rubin, so this is awesome. So here is the shallowest parts of the south rift of Loihi, and it kind of points out a couple of different features. In the center, he sees a mound that tops out about 1,200 meters below sea level. Somewhere in here, yeah. And this area is called Kapo's Mound, which is a site of weak venting. Down a rift, at about 1,300 meters depth, is an area known as Naha vents. It's one of the most active areas we know for venting away from the summit region over there, but also kind of low temperature, probably in that 30-degree range, if I remember correctly. So, and then here, what looks like an eel, but is actually a fish. Nope, didn't come out that much larger. So, all right. So yeah, let's work our way back here to the front page of this Loihi area, and let's look at the seismicity summary, because that's another awesome aspect on this page here. And so they talk about a 2017 swarm. Here's a map of that swarm in 2017. 1995 swarm, 1986 swarm right here. They mentioned 2005. 2001, although the image is no longer loading here. 96 swarm. Let's scroll over a little bit here and show you guys up into 96 how intense that swarm was, what a large peak of earthquakes that was here in this kind of yellow bar graph on the right. All right, so let's keep going and wrap this up for you guys here. 1996 earthquake swarm right there. You guys can see how it was more centered underneath the summit and maybe a little bit more on the west side of the volcano there, unlike the east where we're seeing today in the last couple of days. So let's go back. Let's look at 1996 slightly more closely. And you guys can see, the two possible eruption windows here, these little, I'm not sure if it's the pink or the red right here. These are the different areas where the different ages of the rocks came back based on their polonium-lead eruption ages right here. So without going into any details, earthquake swarms as they occurred on Loihi could have a little bit more finer detailed. And some more maps of the seismicity there, so you guys can kind of look at this on your own time. And just to highlight it once again, let me go back here to the front page. And let's click here so you guys can see the web address of this site right here. And of course, so there have some other things here. They have some updates. Updates go back to 2005. They have recent activity, goes to 2017. They have a rock gallery, some of the rocks brought up, some of the rocks in thin section. This is what an olivine crystal looks like in thin section, and some clinopyroxenes in thin section. Topic for a different video, different day. So some of those rocks look like in their actual hand size samples right there. Right? Some lava, some crusty lava, right? Some fresher looking stuff, some older looking stuff. Right? So where are we at here? So rock gallery updates, 1996 summary, expeditions. You guys can see some of the lists of expeditions to Loihi. It's something that's actually monitored fairly frequently. I'm going to link to some videos here. And here's that video I showed you guys a little bit of, dive into Pele's Pit, and then some kind of broken up parts of those you guys can check out for some more of these videos as well. All right, so, and then there's one more on YouTube as well from Think Tech Hawaii, but that's something you gotta find separately. Maybe we'll perhaps review that in the future if this swarm reactivates or if this information continues to be relevant. So there you have it. Let's go back to the USGS page here. Let's close our key. Let's give it a reload. And let's see if there's anything new here on our USGS. And let's just show you guys, just for the sake of it here, let's go to the main USGS webpage right here. Show you guys, let's let it load properly so it looks nice and pretty. Oh, it doesn't want to. Okay, but if you click on earthquakes here at the top, then it'll take us to this earthquakes page here. And then here is where we can click our, whoops, that's not what we want. We want filters. This doesn't seem to be loading very well properly here right now, but okay. Our Loihi earthquakes page. And there are the events right there. So we can kind of see the glance. There's been nothing colored red, nothing within the last 2 hours on a map. All right, guys, so that's the Loihi update. If you guys want information on Mauna Loa and Kilauea, check our update yesterday with Ikaika Marzo and Dane DuPont. A quick summary, things are fairly stable. The signs are similar to before, and there is nothing changing very quickly in a sense where there needs to be any concern about it. So I'll check out you guys' questions right here. Let me scroll through and see if there's any questions that I can answer for you guys before I sign off. And Pele waking up again. Well, good question, right? This could well be the sequence to eruption, right? Recap in 1996 is that there was about a week of these kind of smaller earthquakes before really ramped up to the magnitude 4s. So if something continues, if it reactivates in a couple of days, then maybe so. But perhaps this will be a one-time pulse like we saw in 2017 or 2005 or some of those other years like that as well. That kind of brings to mind, I got some comments yesterday. I should have a better background for myself, right? So I got an image here of Pele and her sister, Namakaukahi. Pardon the butchering of the pronunciation there. By Eruption, right, that was hanging in a Jugger Museum for many years, showing the battle between his sisters as Pele is trying to come up through the ocean. The ocean's trying to put her out, right? So there you go. That may be as much as we know of Pele right there. So let me see. Submarine volcanoes. All right, you guys. So I think I've got the comments covered. So thanks for joining us. Mahalo and aloha.